So here is the solution to problem E. This is the first one that doesn't have one of every element. So we know that we need to factor the numerator and denominator, and out of the numerator I can factor in x, that's what I see as common, so I'm left with x squared minus 9 on the numerator, and the denominator is x plus 2 and x plus 1. And then I can continue to factor that portion of the numerator to be x plus 3 and x minus 3. And then I have my x plus 2 and x plus 1. All right, so now I'm going to make my list of my zeros, my vertical asymptotes, my holes, and my horizontal asymptote. So my zeros, where the numerator equals 0, so I have x equals plus and minus 3 and 0. So I got 3 zeros there. And then my vertical asymptotes are at x equals, negative 2 and negative 1. Those are my zeros. My vertical asymptotes. And notice that they don't happen at the same time, right? I don't have a 0 in the numerator and the denominator at the same place. So I actually don't have any holes. And then I got to look for my horizontal asymptote. And I see that my power of my numerator is bigger than the one in the denominator. So I don't have a horizontal asymptote. So I'm going to write none. So if you are taking the AP part of this class, you should look into the next video where we talk about what kind of asymptote it is, because we're going to talk about oblique and asymptotes, which are just non-horizontal asymptotes. They're not too bad. So anyway, now it's time to graph this thing. So I graph it, and I know that I have a 0 at negative 3, 1 at 0, and 1 at positive 3. I know that I have a vertical asymptote at negative 2 and negative 1. Whoops. And so really the question is, where is this function going to exist? So I just need to figure out, well, is it positive or negative, and where it is. So in one of the previous videos, I told you if you look at the biggest powers here, you can kind of get a guess of what the overall shape is going to be. And it is going to be linear, which means it's going to be x to the 1. So as I go off towards infinity, x goes to infinity, I'm going to go up towards positive infinity. And similarly, I'm going to come down here towards negative infinity, because this overall is going to look like the function y equals x, which is that way. So I can start sketching this in. I know it's going towards infinity. I know it's going towards negative infinity. Because there's no duplicity, I know that every time I go across a 0 or an asymptote, I am going to be changing signs. So from here to here, between here and here, I'm going to go up. I could do my positive negative test. I am going to be negative inside here. This is new. I got to be negative and approach both vertical asymptotes. I got to go that way. I just, in red here, if I do my shape like this, I'd be inferring that I'm creating 2 zeros. There's some 0 here and some 0 there, so that can't be right. If I did something like this, I should have kept the color red. If I did something like that, well, that would be creating another 0. So that certainly isn't it either. So I'm either doing a U or an N. Kind of looks parabolic-ish. I'm going to change sign again, so I'm going to be coming up to my vertical asymptote. I've got to go through my 0. I'm going to be negative over here. And that is it. Again, if you need to check the signs in between, you definitely should if you're in doubt, but that's the way that goes. Thanks.